I am going to talk about global warming revisited. The reason it's revisited, I got introduced to global warming here in Linda. And I was in a panel discussion in 2008. And it was a panel discussion about global warming. And I didn't really want to participate. But they said you really had to. And so I spent maybe half a day or a day or so looking at Google. And I was horrified by what I found. And so I got interested in global warming a little bit. And because I was on this panel discussion, I looked at Google, and I looked at Gaber and global warming, because I've been on one panel discussion. And I got roughly 40,000 results. If I look at my mind and look at my name and say Gaber and superconductivity, I get much fewer results. Global warming is really a hot topic. And what I said then, and which I still believe, is that global warming really has become a new religion, because you can't discuss it. It's not proper. If you say global, if you look at Linda here today, then all the people who are, notable people, they have said climate change in their talks. All of them have said it. I don't know whether they know what they mean, but they have said it anyway. Everybody talks about climate change. So the American Physical Society, which I was a member, said the evidence is incontrovertible that global warming exists. Now think about that. This is a physical society. And they say you cannot discuss global warming because we believe it's happening. It's like the Catholic Church. There are lots of incontrovertible truth in the Catholic Church, I'm sure. And here there's an incontrovertible truth in the physical society. So the only answer to that is to resign. So, and that actually made quite a much more story than I thought it would have. So global warming really starts with these two people, Al Gore and Pakuri, or however you pronounce it. And what they did, they made this curve popular. I know that's hard to read from the audience, but on the vertical scale is degrees in 0.1 degree. So roughly 1 degree is the whole vertical scale. And the horizontal scale is in years from 1860 to 2000. And you see the global warming has increased, but the scale is like what dentists use when they advertise by toothpaste, because the scale is absolutely distorted. I mean, there's 1 degree there. And for what does this curve measure? Well, this curve measures what does the average temperature for the world for a whole year and for a whole Earth for 1 year. So there's the average temperature for the whole Earth for 1 year, and that measures in a fraction of a degree. So what does that mean? I think probably nothing. So let me talk about that again. From 1880 to 2015, the temperature has increased from 288 to 288.8 degree Kelvin, 0.3%. I think the temperature has been amazingly stable. If I take where I live in Albany, New York, there are roughly 80 degree K difference between summer and winter at some time. And so would you think that 0.8 degree average on the Earth makes any difference to the climate in Albany? Is that sensible to you? Oh, the wrong way. So here is then where the temperature is measured. And you see there's point on the graph, so if you can read that, north of 60 degrees is 167 measurements. Between 30 and 60 degrees is quite a lot of measurements. The United States is all covered with things and stuff. So if you go finally to the South Pole, there are 8 thermometers, according to NASA. That's all they have, including the South Pole. 8 thermometers. And so if you had 8 thermometers to measure the average temperature in Germany, where would you put those 8 thermometers? You know, 8 thermometers for the continent is nothing. And the fact is, as I deal with the South Pole, there had never been as cold on the South Pole as it is right now. There's more ice than there ever have been. And so, but people don't talk about that. They talk about the North Pole, where they have a warmer climate at the present time. And the other thing which upset me is that what is the optimum temperature for the Earth? Is that the temperature we have right now? That would be a miracle. Maybe it's 2 degrees warmer. Maybe it's 2 degrees colder. But nobody has told me what the optimal temperature is for the whole Earth. This is a little bit like American foreign policy. The foreign policy wants things to be as they are because we have it good in the United States. But even the foreign policy can't control the climate. The other thing is that both the alarmists and the deniers, I guess I'm quoted as a denier, measures the average temperature for the whole Earth for a whole year to a fraction of a degree, and that result is significant. Of course it's not. How can you possibly measure the average temperature for the whole Earth and for the whole year and come up with a fraction of a degree? So I have this slide here. I think the average temperature of the Earth is equal to the emperor's new clothes. Was a boy who said, cried, the emperor has no clothes on. And I would cry out and say, you can't measure the temperature for the whole Earth at such accuracy. I was in Beijing I think it was in 74, 75, and Beijing was a village. There were 3 or 4 cars there, and we had control of one of them. I was back in Berlin, in Beijing, like a few years ago, and you can't cross the streets for cars. And there's buildings which are like 30, 40 stories high everywhere. And so what had that done with the temperature for Beijing, you think? I mean, and if you think that when you measure temperature to 1900, the thermometer was standing sort of in the countryside, and now we go 1910, the more dense population density, and then the thermometers broke, you got new thermometers, and how can you think that I can measure this to a fraction of a degree? It's ridiculous. Now, this is what they have come up with, however, and this is for the last 19 years, roughly speaking. The temperature has not gone up. It's been constant for 19 years, almost as long as the life of the students here. They're probably at 23, 24 years old. So it hasn't gone up. And there was a big peak in 98, that's very recognizable. So what did the people who measure temperature do with that? Well, here is the latest temperature they have measured now, and they see the curve here, and if you look at the edge here, it goes up. I made a bit better one here. The temperature here goes up. How can that be when I just showed you the other curve, the temperature has been constant? Well, the reason for that is that they include now the ocean. But for 100 years, the ocean has not been included. Why do you think they include the ocean? Because it's more accurate, or because they can fiddle with the data? That's what NASA does. So Obama said last year that 2014 was the hottest year ever. But it's not true. It's not the hottest year. So if you don't believe I'm cheating you, here's some satellite data, and this is the peak in 98, and you see basically the satellite data shows the same thing. The temperature has not increased. So what is then a greenhouse effect? Well, without the atmosphere, the Earth would have been roughly 35 degrees warmer, roughly speaking. Now, from 1898 to 1998, the temperature has increased 0.8 degrees. And the CO2 concentration has increased from 295 to 367, or roughly 72 parts per million in 100 years. That's what has happened. That's the fact. I'm not making this up. Now from 1998, which is basically the hottest year, the CO2 has increased from 367 to 403, roughly 36 parts per million. That's half of the previous increase. So why hasn't the temperature increased 0.4 degrees then? I mean, if you're a physicist, for heaven's sake, and here's the experiment, and you have a theory, and the theory doesn't agree with the experiment, then you have to cut out the theory. You were wrong with the theory. See, that's half the thing. It should have been, but it isn't. So you can't believe then the people who are the alarmists say that CO2 is a terrible thing, and therefore you have to not drive and use solar cells and stuff because otherwise the world will go to pot. But it's not true. It's absolutely not true. So nature, in its wisdom, this was happened actually in 2012 when I gave another talk in global warming here, has come up with a magazine. And they want to cash in on the fad. My friend said I shouldn't make fun of nature because then I won't publish my papers. But I don't publish my papers anyway, so I'm safe there. So they had an article in there, for example, that corn yield in Africa decreased 1% for each day over 30 degree Kelvin. See, that's a very difficult thing to determine. But they published that article anyway. There was nothing saying in Nature that in the United States we put 10% alcohol into gasoline. That's the most stupid program America ever done. But all the gasoline should have 10% ethanol in it. And that comes from corn as well, from corn grown in Iowa, I guess. And that's food. So for reason we do this, that food is much more expensive now because we do this. It's very costly and very stupid. But that's what the United States, sometimes the United States do stupid things. And nobody mentioned nature how important the CO2 is for plant growth. If you have more CO2, the plant grows faster. People use greenhouses and put CO2 in greenhouses to get a higher yield. But now, since the CO2 has increased, we get more plant and more grows faster. It's a wonderful thing, but they don't talk about that in nature. And also, nobody says big trees here in Lindau, for example, the beautiful trees are actually starving. But when a plant developed photosynthesis, there was much more carbon dioxide in the air. And so they could use much more, but there isn't any. So the plants are really starving. But they don't talk about how good it is for agriculture that CO2 is increasing. Here's another thing from nature, just to show you how ridiculous things are. There's a guy here says, or the guy or girl, I don't know, that the shrinking victims because of global warming is cotton, corn, strawberries, etc. These are things that get smaller because of global warming. So I read out strawberries here because they grow strawberries in Italy, and they grow strawberries in Norway. I never seen any difference in the size of the strawberries grown in Italy and Norway, but apparently they are. And if you're going to make a statement on that, how many strawberries has to count and weigh and deal with? See, it's ridiculous. And then it says here, herring is also smaller. But we've catch a lot of herring in Norway. I never heard anybody say that. But they claim that all these things, lynx, wood rats, squirrels, shrimp, scallop, cotton, corn, everything gets smaller because of global warming. Published in Nature. So unfortunately, it is not true for people. So So here's another one. See, all this you can do, which I did when I went on that panel discussion. Here they say melting Greenland. And you look at that picture, it's carefully done, some people standing in the ice, and a river flowing off, and you think Greenland will disappear. But the information on the internet, which is wonderful, and I looked it up, there are 4 harbors in Greenland. And this is the name of the harbors. I won't pronounce them, but you see the coldest years include 1992, 1997, and so on. The one here are the coldest years. And here are the warmest years. And so the warmest years basically the 1930. And those are the facts. Those are the temperature the people in the harbors in Greenland has measured over the years. And it doesn't look like it's getting any warmer. I mean, I don't understand it. Where does the data come from? Who says what it says? Now, of course, global warming is supposed to cause the climate change. That's what it was. But the climate changes anyway. The climate has always changed. But the people who believe in global warming said the reason climate changes is because of global warming. And the World Meteorological Organization said you need 30 years to determine the climate. So this is a difficult slide to see here, but this is the rainfall in lots of places all over the world. But if we focus on this one here, this is the Dust Bowl in the Midwest in the 30s. You see we have the Dust Bowl there. And you look at here in Africa, the huge amount of rain. The climate has changed everywhere, all the time. And that was before we talked about global warming. And the people in the Dust Bowl, people know how to move to California. So the Steinbeck wrote the story of the Grape of Wrath about that. It was a very wonderful story. And so this has happened all the time, happened everywhere, and it's nothing to do with global warming. So when I ask people then, why is the climate change? Why? The temperature has not changed, so why do they talk about it? Another thing which amazes me really is that when they talk about climate change, it's always to the worse. See, the climate also changes to the better. And if climate changes, you have a 50% chance anyway, you got to be better someplace, for heaven's sake. It can't always be to the worse. So then comes the clincher. If climate change doesn't work to scare people, we can scare people talking about extreme weather. That must work. So here is the extreme weather. And the question is the ocean level rising? Here is a graph. It's hard to see where you sit again, but this scale is in thousands of years, and this scale is in meters. If you look at the recent scale, then you see here, this scale now, you can maybe read that, and this scale here is in centimeters. And for the last 100 years, the ocean has risen 20 centimeters. But for the previous 100 years, it also rose to 20 centimeters. And for the last 300 years, ocean has risen 20 centimeters 100 years. And so there is no unusual rise in the sea level. And to be sure you understand that, I'll repeat it. There is no unusual sight in the sea level. And here is the hurricanes in the United States for 150 years. Hurricanes are supposed to be much worse now because of the weather has gotten 0.8 degrees warmer. I mean, on the average. But you see, there are no such thing. If anything, we've entered a period of low hurricanes. See, these are the facts. I don't make up these facts. And actually, when I gave this talk in Linda in 2012, the criticism I got, I'd never published anything in global warming. But you don't have to publish things. You don't have to even be a scientist to look at these figures. And you understand what it says. And the same thing is for the tornadoes in the United States. It looked like we're in a low period in the last few years. That's only 50 years of data or so. But see, what people say is not true. I talked to a journalist yesterday from D-Site, and he's supposed to be here. I don't know if he's here or not. And I asked how many articles he published, but this says that global warming is a good thing. And they probably don't publish that at all. It's always negative, always. So here is a picture, see how ridiculous things do. I hate to make fun of Norway because I'm Norwegian, but I think I can deserve this anyway. There's an oil platform laying about there. That is 200 miles from the coast of Norway. It's an oil platform. It's a very, very lucrative oil platform. And what they're going to do with that, they're going to electrify it. On the platform, of course, they have lots of natural gas, and they have gas turbines and stuff. There's no problem with power. But to save on the platform, to save for the carbon dioxide on the platform, they're going to electrify it from land. It costs billions of money, crowns anyway, a huge amount of money. But the government of Norway has decided that. Hopefully now, when the oil price has fallen by a factor of 2, maybe they reconsider. I hope that. Because what they're going to do, all the gas they save by not using gas generators, they're going to send to Europe. What is Europe going to do with the gas? Burn it, of course. So, I mean, there's no saving here. They're just an expense. There's no saving of CO2 or anything. It's just ridiculous. So here is now what I worry about very much is the conference going to be in Paris in November. And I really worry about that. Because the conference was in Copenhagen, that almost became a disaster, but nothing got decided. But now I think the people who are alarmists have a very strong position. And so the physical society always have made up their mind, so I don't have to worry about them. And now let's look at what they say. The evidence is incontrovertible. Global warming is occurring if no mitigation is taken, significant disruption of Earth's physical and the cloud system and so on. Everything is go to hell. But the facts are that in the last 100 years or so, we have measured the temperature. It has gone up 0.8 degrees, and everything in the world has gotten better. See? So how can they say it's going to get worse? When we have the evidence that if it's true that they can measure, at least they believe it, when the temperature has gone up 0.8 degree, everything, we live longer, we have better work, better health, better everything. But if you go another 0.8 degrees, we're going to die, I guess. So here is then what we should worry about. This is refugees trying to cross the Mediterranean. And so this is a boat, and these people are not fleeing from global warming, they're fleeing from poverty. If we want to help Africa, we should help them out of poverty, not, try to build solar cells and windmills. Here's another tragic picture. These are Syrian refugees. There are supposed to be 5 million of them. And I ask you, are you wasting money on the climate like solar cell and windmills rather than helping people? See, these people, when you spend, I look at Linda here, there are a lot of solar cells on the roof. These people have been misled. It costs money to do that. And so, and windmills cost money. So here is a very nice, I know I can't convince you by speaking here, but I can show you this book called The Rational Optimist by Matt Ridley. It's a wonderful book. Actually, his main point is that we have it so good today because we are the only ape with barters, with trades. Human, as an ape anyway, they trade. No other animals do that. That's why we have taken this, so much advanced from other animals. And he also talked about but we could change from animal power to steam engine and so on, and then we can go to coal, and then we can go to oil, and we get cheap energy. And cheap energy is what has made us so rich. And now suddenly people don't want it anymore. See, we should continue. And people say the oil companies are the big, bad people. I don't understand why they are worse than the windmill companies. General Electric made windmills. They don't tell you it's not economical because they make money on it. But nobody protests, but they protest to Exxon, who makes oil. I mean, they're very good companies, but their companies are efficient, and that's why we have it so nice today. So here is a statement by Obama. He gave a recent speech at the college in the United States, and he said, "No challenge poses a greater threat to future generation than climate change." That's what he said. That's a ridiculous statement. See, the United States probably kills maybe a few hundred people a day. They probably have killed 1 million or several million people the last 10 years or so. We've been at war. And the biggest problem Obama faces is climate change. How can he say that? And I say this to Obama, "Excuse me, Mr. President, but you're wrong." See, he's dead wrong. And I said that once I was part of an ad in the Time magazine, and I said the same thing. Because I think Obama is a clever person, but he gets bad advice. And in global warming, he's all that. See, I would say that the global warming basically is a non-problem. Just leave it alone, take care of itself. I could give you one example of that, and this is a little difficult, but I got it from a man named Eli Sampson. And he said, consider a large room, 20 by 20 by 10 feet. That's a large living room. And now I want to seal this room off from the rest of the world. And in the rest of the world, you have all these evil cars who have exhaust and spew out carbon dioxide in the atmosphere. So the question he raises then is after 1 year, when this room has been sealed off, how many matches do you have to light in this room to catch up with the cars? Any guesses on that? Probably nobody wants to guess that. But if you take this room and so many matches you have to light, if you light one single match, it brings the room up to 20 years of driving. 20 years. One match in a big room. It's the same number of carbon dioxide as all the cars in the world, which is 1 billion cars. Physicists are very good at this calculation. I was worried about when I got this letter from him, and I checked it. And on the internet, you can find how many cars there are in the world. You can find how much they drive, and you can find all sorts of things. So you see, it's just one of these things. And it's hard for me. It's really very hard for me to understand that almost every government in Europe, and except I think Polish government, are worried about global warming. It must be politics. So finally then, I think what we really have to do, we have to learn to live with change. It's climate changes, climate has always changed. We can't control that, so there's nothing we can do. And here is a picture of me and my wife when we got married 60 years ago. And here you can see how we have changed. And we have to live with that. And also you see what we changed, we have a color photo now. See, it wasn't color when we got married, so that's a change. And I will also say, so far we have left the world in a better shape than when we arrived, and this will continue, with one exception. We have to stop wasting huge, and I mean huge amount of money on global warming. We have to do that. But that may take us backwards. See, it's the people think that things are sustainable, but they're not sustainable. So anyway, that was all I'm going to say. So thank you very much.
people that they have been grossly misled, if not lied to, about Benghazi, keep your doctor, keep your insurance, IRS, all of that kind of stuff, because it'll make them think maybe we're being misled on the climate change issue. So just keep repeating that the true environmentalist out there, which is 80% of the population considers themselves an environmentalist, that you need to go and talk to those people and tell them that the true environmentalists have been misled on this issue. And you can get their attention. Now, the three good folks up here, Tom Weissmuller, he gives an annual regional weather forecast each November in New York City on New York City radio. And Tom has a stunning track record that includes a couple of years ago, no snow, and then he also forecast the brutal snow and heavy snows with warm spikes in between of this past winter, and he did all of that before those things happened. So way to go, Tom. Dr. Hal here, he's the right climate stuff leader, and he is a real rocket scientist. I say genius, and he blushes. But he's been instrumental in solving all of those early rockets that blew up because they had such vibration problems. And not only did he do that, he laid out the software for how these pilots had to land those capsules on the moon so they wouldn't flip over. So you're going to hear a good story from him. We've got Colonel Cunningham sitting down here on the left. Walt and I go back a few years ago, having triggered a letter to NASA admonishing NASA for making unsubstantiated claims, alarmist claims about global warming. It got international attention, but then it faded pretty fast because it didn't have any impact on our commander-in-chief. He ignored it. And anyway, that's that. In addition to his bio that you have in the thing there, Walt has degrees in physics and geophysics, so he's more than just an ordinary astronaut. He's also a physicist, and he was founder of Earth Awareness Foundation and was also on the advisory board of the National Renewable Energy Lab for 5 minutes. Tom, go get him.
Thank you very much, Leighton. Let's see if I can get these slides to work. Not quite. You all had this card in your packet, so my contact information is on there, so I'm not going to spend any more time on it. We have a world here. It's your world, but it's kind of been taken away by Al Gore and the IPCC. Now, how did they take it away? Well, they told you sea level was going to rise. In fact, this is the specter that you're getting. This is Heidi Cullum's book, Weather of the Future. This will never happen. Not in anybody's lifetime in this room or anybody anywhere else. But it does sell books. And that's one of the problems. We're being sold a bill of goods. This is let me go back into the past. About 130,000 years ago, 120,000 years ago, we had sea levels approaching what we have today, right up here. Then the giant glaciers formed when they started melting 18,000 years ago. Sea levels rose again, and now they've kind of flattened out. The IPCC is predicting something else. They're saying that by the end of this century, we're going to have 1 additional meter of sea level rise in their highest, what they call them representative concentration pathways. And they're related to CO2. More emissions, the greater the pathway. 1 meter is almost, it's about 40 inches. That's an awful lot of sea level rise in a century. Now, not to be outdone, U.S. Army Corps of Engineers decides, well, we're going to go for 2 meters, 1.8 really, and they have 3 different pathways. Scenario 1, 2, and 3, and well, this is the Army Corps of Engineers. Let's see, this is not working. There we go. Let me go back one more. Did I get the right one here? Yeah. This is now the National Climate Assessment that was just published a few weeks ago. Now they're saying 6.5 feet. The lowest is 20 centimeters down here, and that is still double the rate that we've had sea level rise in the last 170 years. They're never going to see the top one either. This is Jim Hansen. Now Jim Hansen, by the way, if we go back, in 1988, he was asked by a reporter, how do you see things in 40 years? And he says, well, you see the highway down there, the West Side Highway outside of his office? It's not going to be there anymore. Based on a doubling of CO2 from pre-industrial times. Well, right now we've gone 25 years into that 40 years. We've had 1 inch of sea level rise. There are 10 feet to go for him to make his prediction, and it's got to happen within the next 15 years. You take a look at the, let's see. This is Jim Hansen's slide where he decided, realizing that sea level was not rising, he said it's really going to be exponential. So by the mid-century, it really isn't going to rise at all. You won't even be alive here, neither will I. And yet we're going to get 4 meters of rise. Now this is meters, not feet, in the last 20 years of the century. Don't hold your breath on this one either. This is La Jolla. Now you heard about La Jolla this morning. Scripps Howard is there. I go back here, let's start it again. This is in 1872, the same piece of land. The sea level hasn't risen. I'll go through this one more time. Same beach, same place. So there is sea level rise, but not much. So what's really causing it? Well, we have 3 different sources of sea level rise that we can measure, 3 different metrics. We have tide gauges, we have American satellite and French satellite, and we have NVSat, which is the latest European satellite. The thing that is, first of all, you notice the metrics are all different. Tide gauges average about 1.7 millimeters a year. Topex Poseidon 3.1. NVSat is all over the place. But the characteristic they all have in common is they're all linear. They're all measuring a linear trend. And are they perfect? No. Let's see if I can. This is what a tide gauge looked like. This one happens to be up in New Hampshire. They're all over the world. Some have been around for a long time. Now, parts of the world have sea levels subsiding and raising. Why? Because the land next to it is subsiding or increasing. Some of them are more reliable. They've been around. There is a bias to them. Why is there a bias? Well, people tend to put tide gauges in where the sea level is, quote, rising or their land is dropping. So the coast of Norway doesn't have too many, but Holland has a lot because they're worried about it. So there is a bias in even the tide gauges, and they are direct measurement, and they are still linear. This is what the permanent sea level site from the British looks like. You click on your city, and you get a map that looks like that. And this happens to be New York City. It's linear. However, sea level is rising. Well, why? They put their tide gauge on a battery in New York City. The battery is landfill, and they're putting buildings on that landfill. Well, they're going down. Near New York City, New Rochelle, Port Jeff, sea level is fairly static. This is a subset of that time period. Boston's the same, by the way. After 1960, Boston sea level goes up because Boston is sinking. They put up 19 skyscrapers in 20 years. Let's see. Okay, here's the brilliant Axel Merner put together a way to really look at this. And what he did is he took all the tide gauges in the United States. He grouped them into parts where the land is uplifting, where the land is going down. You notice there's more of those. And in the center, you can actually tell what the real tide gauge, what the real measure of the sea level is as far as the tide gauges are concerned. The guy's a genius. This is what satellites do. This is the other measure. This is Topex Poseidon. They fly over the ocean. They look at the ocean topography. And it's very hard for radar, by the way, to reflect off a wave. Why? Because If you have a high wave and radar hits it, it bounces off and doesn't get reflected. So you have to increase the footprint that you're measuring. And when you do that, usually you have a lot of wave action in low pressure systems, which actually makes the sea level rise. There are all kinds of different changes that can happen. However, the measure is still linear. This is what the Topex JSON group looks like in space. This is what the University of Colorado puts out as a measure of sea level rise. Again, it's linear. But look carefully at this area right here. Here we have in the late 1990s, and also here you have a tremendous increase in sea level. Let's see if I can get the dates right for this. Yeah, 1998 to 2011, big rise. The fall here, by the way, is due to rainfall falling on Australia. They had tremendous storms, and what it did is it replenished the Australian aquifers and didn't go back into the ocean. So you actually have a little drop in sea level here. Here's the other rise. Those rises are significant. Let's see. Axel Murner said, no, we got to change that chart and flatten it. Why? Because the stations were grounded improperly. There's a paper of his. I'll give you the citation for the paper in the Q&A if you need it. Axel Murner is quite correct, maybe not that severe, but we're going to find out how correct in a minute. This is the problem with the satellites. The satellites aren't that precise. The resolution, the best resolution is 23 millimeters in wavelength. You're trying to measure something 1 and 2 millimeters, and you're using a yardstick that can't measure it. It's like measuring this little box here with this yardstick, and it's quite difficult. And how do you do that? Well, you make 6,000 of these measurements, and you hope sooner or later you get it right. And that's exactly how they measure it with the low resolution they have on the radars. Tracking error is also in the 20 to 40 millimeter range, not good. This is the Europeans' answer, a flying boxcar. It's called NVSat. It has sub-millimeter resolution. This is what it looked like in the lab. NVSat, notice, is different. It actually, this is the raw data from NVSat a couple of years ago, about a 0.5 millimeter per year sea level rise, much lower than Topex Poseidon, which is in the 3 millimeter range. Well, how does that happen? What do we do about that? First of all, they adjusted NVSat a little bit. This is how precise it is, by the way. You notice the high points are always in January of each year. There's a 2 millimeter variation each year in sea level rise. This is very, very precise. Now, how come that happens? Well, first of all, we have something that's called the oceans expand when you heat them. Well, the view in January of the southern oceans is basically all water. This is courtesy of Guy Otwell. If you imagine the opposite, the winter view in the south, which is our summer view, you have Asia and North America, lots of land, but not a lot of ocean. So therefore, you have the sea level actually dropping because thermal expansion gets lower. So you have within any given year, you have that 2 millimeter range. But you have a real precise satellite to show you, which is great. This is the original raw data from NVSat. Then they corrected it further. Here is the big problem. This is the sun. This is our solar cycle. This is the sunspot cycle. Remember the years I talked about that were crucial in the satellite imagery. Right around here, we're showing sea level rise. And right here, 2011 to 2014, we're showing sea level rise. Now, why would solar and sunspot activities make the oceans rise? Is it thermal expansion? No, it really isn't. What's happening here is that when you have high sunspot activity, the Earth's atmosphere itself expands into a balloon. People think that these satellites fly in space. They don't. They fly in the upper reaches of the Earth's atmosphere. And it looks something like this. This is Brownian motion. You have to imagine these as being little particles up where the satellites fly. And if you expand the atmosphere, there's more of them. You have a decimal point, 6 or 7 zeros before the first one shows up that will impact the momentum of that satellite. But it does happen. It's called orbital degradation. And orbital degradation will make a satellite think that the sea level is going up. Why? Because the satellite is going down. This is the difference, Envisat and Topex Poseidon. We had to resolve that difference between 1 and 2.6 millimeters. And the only way to do it is this way. Because the tracking resolution doesn't work, this is called the transit measurement. What we do is we wait 1 year and we track when a satellite crosses that line. If the satellite crosses the line a little bit early, then we know it is in a lower orbit. With an atomic clock, we can be very precise at knowing exactly when. It's an experiment NASA needs to do. The Europeans are thinking about doing it. This is something that you will not see, the world that Al Gore and the IPC want to give you. Sorry, folks. This is the world you deserve. It's the world that Axel Murner, Willie Soon, and our group of scientists here want to leave you with. And I want to thank you very much for the privilege. Now, Hal's going to come up here and talk about CO2 sensitivity.
I want to make it clear, I'm representing a team of scientists that call ourselves the Right Climate Stuff Research Team. We're more than 25 retired scientists and engineers from the Johnson Space Center in Houston. Tom, who lives in Maine, is a member. Bob Bowman here is from Maryland. We have others from around the country who have joined with us. And we also have a few people from the Houston community who are not NASA former employees, but they are very highly credentialed research people from Shell Research and Dow Chemical that were studying this climate thing long before we NASA guys got interested. So I want to make it clear that this is a team effort, and I just happen to be the spokesman today. I want to talk a little bit about how the international climate community talks about how sensitive our climate is to CO2 and other greenhouse gases. The holy grail of climate science is trying to define something they call equilibrium climate sensitivity. And it's loosely defined as the global average temperature rise that will eventually result from doubling CO2 level in the atmosphere. If you read the IPCC reports, it's pretty loosely defined that way. And their more recent AR4 and AR5 reports are incomplete and misleading. The double CO2 level in the climate model solutions is artificially held constant. It's a step function forcing. But in actuality, the ecosystem of the Earth removes half of the CO2 emissions we put into the atmosphere every year, like clockwork. But in an equilibrium climate sensitivity solution, they're arbitrarily holding it constant, which is unrealistic. The other thing they don't tell you is that it takes more than 1,000 years for the climate to equilibrate to this artificial forcing and reach the final equilibrium sensitivity number. Our CO2 regulations are based on what's going to happen in the next 100 to 200 years. So equilibrium climate sensitivity is unrealistic, has nothing to do with our climate for the next 300 years. Yet that's what the EPA is using to regulate CO2 emissions. Things have really gotten out of kilter here. The other metric that climate science uses is called transient climate response, and that's defined as the global warming that would result from increasing atmospheric CO2 levels at a rate of 1% per year until the double CO2 level is reached. This also is very artificial, and it can only be calculated with a climate model. But it's more like the slow rate at which CO2 is rising in our atmosphere. Even now, at a fairly high rate of CO2 emissions, our CO2 levels are climbing only at about half this rate. So even that transient climate response metric is not realistic. So typical of climate science over-reliance on unvalidated models and not enough on data is that neither of the two metrics the IPCC uses, ECS and TCR, neither metric can be verified with physical data. You can't catch them. You can't question them. You have to have a very complex climate model to run and get these numbers. To me, they're totally meaningless. If you can't verify your crucial metric with data, what good is it? So I'm pretty, after looking at this for a couple years, I think I'm going to quit calling them climate scientists until they get a metric that can be verified with physical data. Because scientists look at data, not just models. So I want to talk about the difference in these two dynamic solutions that they get with climate models. I'm sorry. Forgot. I'm going to use this very simple spring mass damper system that most of us have a feel for the dynamics of. And I always like to take a complex dynamic model and have a simple model to think about it with. So in the ECS forcing function at the top, instantly you double CO2 in the atmosphere and you hold it constant forever. Artificially hold it constant. Well, think about what kind of force that is on this dynamic system. It means you're starting with the whole system stable and still with a constant wind force on it, and instantly you double that force. You can see what that spring mass system's going to do. With a light damper, it's going to start oscillating. And eventually, due to damping, it'll damp out and reach a new level. And that's analogous to what that equilibrium climate sensitivity would be. Now, talking to climate scientists, I guess I'll call them scientists today, the damper in their models is fairly large, so it kind of just gradually approaches that doubled ECS value. But let's look at the transient climate response, which is the lower forcing function. Just gradually change that. You can imagine what happens to this dynamic system if you start with it at rest and then gradually increase the force. It's just like taking your finger and gradually pushing it up. It's not going to oscillate. It's going to be in equilibrium all the time. And the mass is just going to gradually rise, which is analogous to a rising temperature. So if you gradually increase the force, this mass is just going to gradually move upwards without oscillating. And that's the way our climate is actually behaving with respect to any CO2 warming that's occurring. So our solution of this dynamic system, in which we're going to use temperature as a measure, the solution needs to look a lot like the forcing function. In fact, this really isn't a dynamics problem, it's a statics problem, and you don't need a big complicated climate model to find out how sensitive you are to CO2. And I will point that out in this presentation.
Are you okay?
I'm sorry, I'm looking at the wrong screen. So what we did to get a verifiable climate, we defined a new climate sensitivity metric that we call transient climate sensitivity. It's kind of like the transient climate response, but we're saying transient climate sensitivity is the rise in global average surface temperature due to the actual gradual rise of greenhouse gases in our atmosphere in the year that the radiative force of the greenhouse gas is double with respect to pre-industrial levels. You can verify that because we have data on temperature, we have data on greenhouse gases, and we can find out, and we'll show you how we did it. We can define this TCS value for CO2 only, all greenhouse gases, or any specific greenhouse gas. If you're going to regulate CO2 and you're going to talk about how much damage you're going to avoid by regulating CO2, you need to separate the effect of CO2 from all the other greenhouse gases, because all the other greenhouse gases contribute about 60% of what CO2 does. And when the IPCC talks about ECS, they're usually talking about the effect of all greenhouse gases. So we need a CO2 only transient climate sensitivity value if we're going to talk about the benefits of regulating CO2 emissions. I want to put the double CO2 in perspective. This is where we started from, this very low level. That was CO2 in the atmosphere. This dashed green line is the CO2 level you need in the atmosphere just to get plants to grow. If you don't have that much CO2 in the atmosphere, plants start dying. And we're talking about starting at this very low level, near the critical limit for plant growth, and doubling it. And right now we're about 40% along the way to doubling it from pre-industrial conditions. This is what we allow on the space station for astronauts to breathe, 5,000 parts per minute. I think Walt said on Apollo, we didn't know as much about CO2. His alarm went off at 4,000 parts per million. And this is what you allow on submarines, 8,000 parts per million. And those guys are under the water for 6 months at a time. So in terms of toxicity to humans or any other animals, we're way down here. We're never going to get CO2 levels this high in the atmosphere. You could burn all the fossil fuels on Earth, and you're probably not going to get over 1,000 parts per million. So I want to put this doubling CO2 in perspective. This is the actual rise of CO2 in the atmosphere on a different scale. This comes from ice cores in the Antarctic. The blue part is what's been measured since 1979. And this is our projection for what's going to happen as fossil fuels become scarce. They're going to become more costly. We're going to have to go to alternate fuels. We predict, based on the economic analysis, that we're going to peak out at about 600 parts per million sometime in the next century. I'm going to have to get going here. I'm going to skip over the word charts and just from basic quantum mechanics considerations, if you double CO2 in the atmosphere, we're going to slow down the radiation to outer space, and we will get an equation like this that says the radiative force change in any year is equal to 3.7 watts per meter squared times the logarithm of the CO2 in any year divided by the CO2 level in 1850 divided by 2. So when you get the double value, when this is double this value, this is 1, and we get 3.7 watts per meter radiative force. We're going to force the atmosphere with that. And that gets us to the temperature change should be given by this equation, just based on a linear change in temperature with radiative forcing. So we did a study where we looked at forcing the atmosphere with CO2 or any greenhouse gas. And we also looked at perhaps there were natural phenomena going on. This is the actual temperature data. The Hadcrut-4 data set. And you can see it has a general upward trend, but it's got some oscillatory aspects to it, you know, going up and down that we said, hey, that's not that slow rise in CO2. That's something else going on. And we've, in fact, found a 62-year cycle in the data. This is a 1,000-year cycle that was going on before we started rising CO2 in the atmosphere. So this is how we model that Hadcrut-4 data, and we fit it with the CO2 forcing function. The wiggly line here is a 62-year cycle we found in the data, and the dashed red line is the maximum effect that CO2 could be having. Notice it hits the peaks of this red line. The green line, yeah, okay. So this is the way we determine what the transient climate sensitivity was. And there's some more charts here. You can read our paper at our website. And our website was on the opening chart. It's called therightclimatestuff.com. Thank you.
I didn't do that, they did. Well, I have to tell you this, that I'm honored to be here with real climate scientists. And even in the last 18 hours, I've heard so much here that just reaffirms the kind of beliefs that I've come to over the last 15 or 20 years as I've been interested. And while I'm not a climate scientist, I am a student of environmental science. And I consider myself an informed critic. You know, while our home planet is, from orbit, it appears very small and fragile, but humanity has been adapting to continuously changing climate for the last 1,000,000 years. Climate science was a respected field of science up until about 30 years ago, and that's when alarmists began to ignore scientific discipline. Global climate change is a scientific question, and it's dependent on scientific data to understand it. Unfortunately, subjective opinion has been carrying the day. Excuse me. And human-caused global warming has become an issue that's been shaped by opinion, politics, and financial control. Well, I'm not here to make the scientific case against human-caused global warming, anthropogenic warming, AGW, climate change, climate disruption, or whatever the latest phrase is that alarmists are using to just promote their claim that humans are controlling the temperature of the earth. My fellow panelists and many others here already in the last day have disproven these alarmist claims. Their honest science enables me to battle on other fronts and discuss some other things that I believe we should be doing, climate scientists should be doing. Scientists have long known that the sun, the oceans, and variations of the Earth's orbit are the principal drivers of our changing climate. And while we may not fully understand all of the mechanisms or interactions that are involved, after hundreds of years of empirical data, that became an accepted theory of climate change. Well, as you know, scientists have always questioned accepted theories. Back in the 1980s, a small group of individuals became very concerned about the Earth's temperature and what it might do in the future. I hesitate to call them scientists because they abandoned the scientific principles by which their guess about future temperature increases and its cause could achieve scientific acceptance or rejection. Global warming alarmists focused on the small temperature increase since the Industrial Revolution, and they hypothesized that the tiny amount of carbon dioxide that humans were generating was controlling the temperature of our planet. Excuse me. Well, I guess I got to come on one at a time here. Well, okay. Sorry about that. They could have made their case by collecting and making available solid evidence to support their hypothesis. And two, by defending their claims in the court of scientific inquiry, not in the court of public opinion. Instead, they refused to release their data that would permit other scientists to replicate their results, if that was possible. Today's public really doesn't know what to believe about when it comes to humans causing global warming. Politicians, in the absence of knowledge and understanding about climate science, have put themselves out on a limb from which they find it very difficult to retreat. The alarmists have managed to sell the media, the media and the public on human-caused global warming, and something that they've invented called consensus science. Those of us skeptical of those scientists' claims are labeled as climate deniers or fake experts or against climate change. Well, instead of presenting data to prove their hypothesis, the alarmists challenge skeptics like us to disprove that hypothesis. And while scientists are best qualified to deal with the scientific and the academic aspects of that question, all of us will suffer the financial consequences of actions that are taken based on bad science. Today's global warming war is a battle to avoid governmental control of energy consumption and the lowering of our standard of living. The temperature of our planet has been changing for 4.8 billion years. And both temperature and carbon dioxide levels are currently near their historical minimums. The last time they were both simultaneously at such low levels is about 300 million years ago. And about 500 million years ago, the carbon dioxide level was approximately 15 times higher than it is today. Even in the past 10,000 years, there have been many occasions when the temperature was higher than it is today. For the alarmist hypothesis to be accepted by scientific community, one, it must be confirmed by considerable evidence, and two, it must survive all attempts to disprove it. The alarmist hypothesis has not satisfied either of these criteria. Most of today's population is unable to distinguish between science and non-science, or between a hypothesis and a theory. The alarmists, they gained immediate traction with environmentalists, the green movement, the media, and eventually with many politicians. Now, in the absence of supporting data, they are pitching to the public, where politics, media, and money play very important roles. The alarmists like to refer to a correlation between temperature and CO2 levels. Well, we all know that correlation is not causation. But just in case, our friend Dr. Roy Spencer, who you may have heard already, excuse me, he studied the correlation between ocean temperature and UFO sightings. Something I should know a little about. And Roy published a humorous article back in April. Sure enough, the correlation between UFO reports and ocean temperature is frightening. Does that mean that we can lower the Earth's temperature by reducing the number of UFO sightings? Well, the only thing that alarmists are able to cite in support of their simplistic hypotheses, I guess, are the mathematical models which they developed to prove that human-caused carbon dioxide is a dominant factor in controlling the Earth's temperature. Well, these climate models have never successfully predicted anything. And keep in mind, models are based on assumptions. That's opinions. If their bases for, if the bases for these assumptions are wrong, the results can never accurately predict future behavior. And as realists, we should be emphasizing that models are not data. Realists focus on empirical data and the scientific process, neither of which support the hypothesis that alarmists have dreamed up. And that is why alarmists resort to consensus science, politics, money. And along the way, they've convinced most of the media that humans cause global warming. They've convinced them that that is an accepted scientific theory. As realists, we've been fighting on the scientific front, and we are winning the scientific battle. With history, facts, and scientific theory all on the side of global warming skeptics like us, why is climate change still a controversial issue? Well, I think it's because this global warming war is being fought on a number of fronts. There's a scientific front on which we're winning. There's the media front, the public perception front, and the political front, which now also encompasses education. Our challenge is to focus on the public's perception of global warming issues. And the real battle today, and where we appear to be losing, is on the media front. The media plays the most influential role in the public perception, and to some degree with the politicians. We have allowed alarmists to seize the semantic high ground. That's a tactic that has helped move the subject away from the scientific arena and into the political and economic arenas. The media, the public, and most politicians have little scientific literacy, with some rare exceptions, I agree, and they show very little interest in gaining it. And that does not prevent the media from playing a major role in this fight. Many journalists are aggressively pushing human-caused global warming, and they influence a great many readers and listeners. Our challenge at this stage in this war is to engage the alarmists on the media front and bring the media and the public back to reality. Alarmists refuse to accept that today's weather is within historical, natural climate variability, and they are reluctant to admit that man has little control over nature. That is why global warming is sometimes referred to as a religion with the alarmists. To take global warming on faith, you have to reject empirical data and what we have learned about climate change over the centuries, and embrace the unproven hypothesis that humans are responsible for global temperature changes. These true believers in humans controlling the Earth's temperature cannot be reasoned out of their position. It was not reason that got them there in the first place. It was emotion and politics. Today, the politicization of science is pushing global warming fears in our universities and in K-12 education. For example, the new Common Core framework for science education states that fossil fuels are the cause of catastrophic global warming. Common Core is also saying that man, not nature, has been the main driver of climate change for most of the past century. While scientists are making it increasingly plain that humans have little influence over the Earth's temperature, the alarmists are still winning on the media front, the political front, and the public front, which means we have to do a better job of communicating. Realists need to engage the alarmists on the media front to bring the media and the public back to reality. We should all be telling the media, and the public not to just buy the opinions of others. That includes my opinion. Look at the empirical data themselves. Emphasize that empirical data is not just another opinion. Emphasize that man's historical ability to adapt to temperature changes and how energy consumption has raised our standard of living. Quit letting alarmists control nomenclature. We should emphasize that the argument is not about climate change. It's about the cause of climate change. When writing and speaking, we skeptics should consistently refer to the alarmist claims as human-caused global warming. Don't refer to it as anthropogenic warming, AGW, climate change, or climate disruption. We should make it plain that human-caused global warming is not a scientific theory. It's how the alarmists choose to look at the temperature change in the ongoing human-caused global warming war. This battle for public perception may be more critical than the scientific front. Human-caused global warming may be the biggest scientific myth-based scam in our history. And this fight should not be beneath the dignity of climate science realists, especially when we're dealing with the media. Thank you.
Very good. Thank you, gentlemen. We're getting ready for question and answer. I want to ask one question to Dr. Howell over here. Dr. Howell, I promised everybody you were going to tell them what you thought the maximum temperature rise was going to be by the end of this century. So I'm going to ask you the first question. Do you want to tell them that?
Yeah. When we determined our transient climate sensitivity value, and we put an upper bound on it of 1.8 degrees centigrade, we looked at our projected CO2 rise for the rest of this century and that transient climate sensitivity, and we predict less than 1 degree C rise by 2100. That's all we can see from the data and our projection of how CO2 is going to rise in the atmosphere from burning fossil fuels.
Yeah, good.